Okay, so we are going to continue on PIC 18 instruction categories. So from our previous class we have seen that we have byte oriented, byte to byte oriented, bit oriented, literal oriented, control, data memory to program memory, and vice versa. But out of these 6 we covered only the first 4, and we have seen basically what does this type of oriented instruction do. Byte oriented, it manipulates the entire byte. Byte to byte is actually a copy paste kind of similar operation. Then we saw the bit oriented instructions, whereby this kind of instruction allows us to manipulate a particular bit. And then we saw the basic concept of literal oriented instructions, whereby these instructions allow us to load a value. Any questions on the instruction category so far? We will be seeing them in great detail. And when we come to instruction format, one instruction is how long? How many bits? 16 bits. So in program memory, one location you can only store 8 bits. So which means one instruction will take up 2 spaces. So there are a total of 77 instructions. And out of the 77 PIC 18 instructions, there are 4 instructions which are 32 bits long, which means it will occupy 4 memory spaces. Now I did remind you all to print out the PIC 18 instructions. Did you all print it out? Okay, good. So one instruction is 16 bits, so the lower byte will be stored at the higher or lower address. The lower byte will be stored at lower address, the upper byte will be stored at the higher address. That's how it is arranged in program memory. And then we went to look into the subject matter of byte oriented format. So we will be seeing in each category all these various formats. So the first one is the byte oriented format. Let's see, where is our So from a PIC 18 instruction set, we are taking this add WF, the first instruction. Why we are only taking one? Because all the instructions have a similar kind of format. They are same format for the byte oriented instruction. So we only will take one instruction to study the byte oriented instruction format. Is that okay? So we have taken the first example, which is add the content of working register to file register. And this instruction have this particular format. The opcode takes up 6 bits. There is 1 bit for D, destination, there is 1 bit for A, and there is 8 bit for file register operation. So this is the description that we have given, right? What is the opcode stands for? Opcode is actually the operational code, which means it's very unique. You can never find 2 similar operational code. So in this case 001001 indicates this is an operation of adding working register to file register, which is very unique to that. And then we have D. What is D? D is destination. For example, whenever you perform addition or subtraction, you will have an answer. And where do you want to store the answer? You will have 2 options, either to store at file register or working register. Why do we have 2 options? Because from the instruction, currently the instruction is able to access to 2 locations, right? One location is working register, the other one is file register. So if you get answer, the instruction can, because it only has access to these 2, it can only store in either one of these locations. Is that okay? So therefore your destination, you can either choose capital F or capital W. This capital F or capital W is what you can write under the D field. So at the D field there, you should write either capital F or capital W. So if you write capital F, the value of D is equivalent to 1. This you have to memorize. If you write W, the value of D is 0. And then you have A. A is actually the bank scheme. There's again 2 options that you can write. You can either write capital banked or capital A. We will see this banked in a while. If you choose to write capital banked, then your value of A is equals to 1. If you write capital A is equal to 0. And what is F? F is the 8-bit file register address. Any questions so far on this format? So this is what we have done. So we are taking one simple example. Sorry, why am I keep on enlarging, because the earlier color is orange, and if I enlarge then only it's easier to see here. That's why I am enlarging. So this instruction is add the content of working register. Now working register is one of the CPU registers, right? Add the content of working register to file register. So remember, the CPU or the control unit knows all the location of the special function registers because they are all predefined. So when the control unit sees this instruction, add the content of working register, the control unit says, okay, I know where is working register. It's my close friend, I know his address. To file register. Now this file register, the address is not mentioned, right? So where do you have to mention it? At the F field here. Otherwise it won't know which file register to add. Is that clear? Are you all following? So if you don't understand, just let me know, like simple as that. So always in this particular subject, I always like to draw in a visual format. It gives us a better understanding on what we are trying to do. So we have working register. We want to add with the content of a file register. Now the working register location is already known, but this file register we have to select an address. So we chose one address from data memory. Remember, all these executions are all done at data memory, so you have to choose a location at data memory. So we chose this, for example, hex 110. So is it a valid address? Why is it a valid data memory address? Why is it valid? Because it's 12 bits. Okay, very good. So now when we want to perform the addition, we want to write the instruction, we found there's an issue, right? What is the issue? Yes, the instruction format only allows 8-bit file register address to be written, but whereas the data memory is 12 bits. And we have seen, in our previous class we discussed, right, why we didn't allow 12 bits out of 16 bits. Did we discuss? Not yet. We discussed. We did. So out of the 16 bits, if we allocate 12 bits out of 16 bits, we only will have remaining 4 bits. And with the remaining 4 bits, you can only have 16 possible operational code. So you have very much limited your operations now. Or the other way, you could say, okay, why don't we just make it 32? Then we can straightaway, address all these 12 data memory bits. But then that occupies a lot of space. So being an engineer means always we try to optimize and try to have the best that we could. So the engineers decided that yes, we're going to stick to 16. 8 bits definitely not possible. 8-bit instruction is not possible. So they say 16 is okay, fine, we'll keep it 16, but we will only allow 8-bit file register address. So out of this hex 110, 8 bits only, you can only take 10, right? That's the only thing you can write in the instruction here. Add hex 10, because even though if you write hex 110, the only value that will be taken is hex 10, the 8 bits value. Now because of this limitation, because the instruction format only allows 8-bit file register address, the engineers, they have done some modification to the data memory. So at the end of this, you will see how smart they came up with a solution to solve a complex problem. Are you all with me? Say something, lah. I'm already working with a lot of electronic things, so I want to interact with people. So what are the modifications done on data memory? Is that okay? Just now we saw that there is an 8-bit 5-register address, right? Now with 8-bit, how many possible locations that you can access? Yes, 256. Very good. So what they have done is, you have the data memory, right? They have divided the data memory into groups of 256. So what is the capacity of data memory? 4096. If I use black, you can see, right? 4096 bytes. If you divide with 256 bytes, you will get 16 segments. So you can see each segments are blue. Can see here. Can you see blue color? Each segment is 256 bytes. So how many segments you have? 16. Now each one of these segments is called a bank. So when you divide, you have total of 16 banks. They call it as bank. Are you okay? Now let's see what happened to the address range. You have address hex, start from hex 000, right? 256 means will become what? Hex 256 means what's the value of address? FF lah. 00 to FF is 256, right? Are you all following? Are you able? If you are unable to follow, let me know. So I don't understand how is FF 256. Anyone has a question? Why you all suddenly so shy? You're not seeing me for the first time, and you all know I won't scold if you don't. If you ask question. So let it go. I mean, let your ego go, or let your whatever that's holding you from asking question. Just ask lah. Simple. So 00 to FF is 256. What is FF? FF is 11111111. 8 bits, right? 256. So from address hex 00 to address hex FF is 256 locations. Now after 0 FF is what? What is after 0 FF? Yes, 100. 256 location from here. 1 FF. What's the next number? 200. 256 from here. 2 FF. And the last one, bank F00 maximum F. Got it? So I'm just gonna put a separating here so I can now I'm gonna, these are 12-bit address, right? These are 12-bit address, so I'm going to break it like this. I'm breaking it into 4 bits and 8 bits. Are you able to see? Are you able to see at the 8 bits it keep repeating 00 FF 00 FF 00 FF 00 FF. Are you able to see the pattern? Then the remaining is actually the remaining 4 bits. Now each one of these segment is called as bank. So the first bank is bank 0, second one is bank 1, then bank 2, and the last bank is bank 15. There is another pattern. Can any one of you detect what is the pattern? The 4 bit is same with what? Yes. Do you see that the 4th bit digit actually denotes the bank number? 0 is actually referring to bank 0. 1, bank 1. The 4th upper enable bit denotes the bank number. Right? Are you able to see? This is 2, bank 2. This is F, bank 15. Are you all following? Very good. Any question up to this point? Any question? No. See, engine is very smart, right? They divided this. So coming back to this point, when we say add working register to file register, and the file register address is given here as hex 10. Now, when you look at within the 8-bit range, there is a hex 10 here, there is a hex 10 here also, right? There is a hex 10 in every bank, right? If you just look at 8-bit value, hex 10, there is hex 10 at bank 0, there is a hex 10 at bank 1, there is a hex 10 at bank 2, every single bank there is hex 10. But which bank does this hex 10 belong to? Can anyone guess from its address? Yes, very good. It belongs in bank 1. How do we know that? That the 4th bit is bank 1. So the actuality we want to, it's actually referring somewhere here, right? 110. So let me just draw here. So hex 110 is somewhere here in between, right, within bank 1. Are you all following? You don't understand. Which part that you don't understand? Why bank 1? What is the address? It's hex 110, right? So what the pattern we saw just now? The upper bit, the upper digit denotes the bank number. That's why it's bank 1. Is that okay? Anyway, if you write 110, 110 is in bank 1. That's what we are doing right now. Here if you put 110, 110 is here within this range, right? So it does fall in bank 1. Now, because it is divided into banks, and memory location can only access one location at a time. Now, because there is hex 10 here, there's hex 10 here, there's hex 10 in every bank, you need to activate the bank. So in order for us to activate the bank, there is another special function register which is known as BSR. This is known as bank select register. So how many CPU registers you have learned so far? What are the names of special CPU registers that you have learned so far? Working register, bank select register, and working register. File register is a normal term. File register is a normal term. So far we have seen working register, status register, and also bank select register is another CPU register. So this bank select register, it only uses 4 bits. So bank select register only uses 4 bit. Can you guess why it only uses 4 bit to select the bank? Yes, very good. There's 16 banks are there. In order for you to choose any of the 16 banks, you only need 4 bits. So how do we actually use this? How do we activate this particular bank? Currently we know we want to add hex 10, but this hex 10 belongs in bank 1. Take note that hex 10 is available in every single bank. So you need to activate one bank. So how do we activate the bank? Is by this instruction. We have not learned this yet, but we'll just use it for now. Move L B. Move L stands for literal value, B stands for bank select register. So move the literal value to bank select register, and it takes one argument. So when you write 1, what it does, it moves the value 1 into bank select register. When bank select register value content is 1, it will select which bank? It will select bank 1. So bank 1 will be active. And then you can actually write this instruction: add working register to file register hex 10. Now because we are using what scheme now? We are using the bank scheme, right? So I'll skip the destination part now. I'll focus on the A. So because we are using bank scheme, we should write capital bank. Now let us see back how does this instruction work. Now remember, the instructions are executed sequentially. So what happens, the first one? Move literal value into BSR. What is the value that you are loading into BSR? 1. So when you load 1 into BSR, what happens? This bank will be active. This bank will be active. Is that clear? Then second instruction, add the content of working register. The control unit knows where is the location of working register because they are special function register, to the content of file register. What is the address of the file register? Hex 10. Then it will check, are you using bank scheme? Are you? Yes. So which bank is active? Bank 1. So what it will do, it will choose the location hex 10 in bank 1. If it chooses hex 10 at bank 1, what is the actual address? 110. So in other words, you can see the address 110 from here also, right? You see this 110. Did you all also notice another thing, that the third digit or the most significant digit is the value that we load into the BSR, right? You see, that's the value that we load. So in other words, this is how many bits? 4 bits. This is how many bits? 8. Total 12. So BSR takes 4 bits to select the bank, and because of the limitation just now, you can only take 8, right? So you have 4 plus 8, 12. You get back 12. Any question up to this point? Yes. Oh, if it's bank 2, you just write decimal 2 there. No need. Okay, very good question you ask. This part here is known as the operand field. Operand field is the input or parameters that we provide to the opcode, or the mnemonic as we shall call it. So in this case, if it's bank 2, then what should we write here? You can straight away write 2, but he was asking, do we need to write D? Remember the prefix that we learned? Do we need to write D or not? Say we don't need to write D. By default in MPLAB, when you don't put any prefix in front, it consider it as a hex number by default. So why don't we have to write anything here? We actually meaning to write decimal, right? But take note, decimal from 0 to 9 and hexadecimal from 0 to 9 are the same. So that's why we don't need to write any prefix. If it's 10, so then you have two options. You have to either write D10 or hex A. Is that okay? Because if you just write 10, it will take this as hex 10. What is hex 10 in decimal? No, hex 10 is not A. What is hex 10 in decimal? 16. Is it 16? It is. But the point? So from 0 until 9, you can straight away write the value lah, no issue. But if you need to choose a bank more than 9, bank 10, 11, 12. So if you want to write it, express it in decimal, then you have to use D. If you want to express in hexadecimal, then you have to use hex. Is that okay? Any other question? Now that we have done the addition, so this is what the instruction we have written so far. Move LB1, this will activate bank 1 and add the content of the working register file register, which is hex 10, and because we have activated the bank, so the actual address is 110. So before we do the addition, can you give one example of value? Caramel, I'll give lah. E9 and EF. Assuming that inside working register initially we had this value and inside hex 110 we have this value. So this instruction will actually perform the addition, right? Add the content of working register to the content of file register, which is given at address hex 10. But is it using bank? Yes, it is using bank. So where is this hex 10 belong? It belongs in bank 1. So the actual address is hex 110. So that's why I have drawn here, put in some value. Say 9 plus 15. How much is 9 plus 15? 8. 24, right? 24 minus 16. 24 has exceeded the base number 16, right? So you will minus. So 24 minus 16, you get 8, and because this has exceeded the base number, you need to have a digit carry. So this is 10, 11, 11 plus E. How much is E? 14. So 11 plus 14, 25. Again 25 has exceeded the base number 16, so minus, so you get 9, and that is also because you minus by the base number, you get a carry. So this is the answer, hex 98. Now the instruction, currently the instruction has only access to either working register or hex 110. So where do you want to store the answer? There's only two binary answer. Why is so long? Just choose working register. So if you want to store the answer back at the working register, what should be the value of D here? You should write W. Is that okay? So what happens to this value? This value will be overwritten with hex 98. So the new value inside working register will be hex 98 because you choose to store the answer at working register. You can also choose to store at hex 110. How you can do that? Instead of capital W, write F. So it will write here at EF and it will overwrite EF with hex 98. Any question up to this point? Any question? If you don't understand, just ask. Now, if there's no question, I'll proceed. If you have question, just ask. Simple. Now, there's also a very favorite, yes. Come again? You're not clear about? Okay. The answer, where are you okay about the how we got this hex 98? Okay. So now we have the answer, but the answer need to be stored in either one of these locations. W, this is W, or F. You can choose to store in any one of these locations. For now, you can just choose. So I'm asking you all to choose. So if you want to store at working register, you should write capital W as the destination. So if you write capital W as a destination, what the instruction will do, it will add the content of working register to file register. Where is the file register? It is actually located at hex 10. Are we using bank? Yes. Which bank? Bank 1. So which means it will select hex 10 at bank 1, which means the actual address is hex 110. It will perform the addition, and now you have the answer. And the answer, because you write W, the answer will be overwritten at working register. So the previous value of working register, which is hex A9, will be overwritten with hex 98. So after this operation, after this instruction, you will see inside the content of working register that's hex 98. At the location of 110, hex 110, you will still see EF. Is that okay? Now if you choose F, what will happen? EF will be written with hex 98 and the content of working register remains the same, A9. Now you may have this question, how do you know what to choose, W or F? That one later you will know. For now I'm just giving you only these two options. Later when we do certain example tutorial 2 questions, we will revisit back and you will understand, oh yes, it is better to store in the working register. Oh yes, it's better to store in file register. You will know all that. So not to worry. Any other question? Yes. You want to activate bank? 15. Either way, if you want to write 15, then you must write D 15. If you want to write F, then you can put 0F or just F. Is that okay? From 0 to 9 only they are the same. After that, it's better to put the prefix. Any other question? The more question you ask, I think the more students will be benefit. Yes. Okay, good question. ADDWF must be put in capital letter or small letter? Anything also okay. So ADDWF can be capital, can be small letter, but the W and bank must be capital. But the new version of MPLAB, it also accepts whether it's small letter. The older one, if you write small letter, like small capital, I suppose to write capital W, but if you write small w, it ends up giving error. But the new one is okay. For the exam, it doesn't even matter. Remember, for the exam, we are just looking for the skills and understanding, not so much on the syntax. But that's why we have the PIC 18 instruction set. It's like a very good reference for you to put where is the comma. Do you see that I actually put a comma here? Add WF, hex 10, comma, W, comma, bank. Because these are three different operands or three different field. This is the F field, this is the D field, and this is the A field, right? That's how it's written in you see this one? ADDWF, F, comma, D, comma, A. Any other question? Another important aspect is how do we actually convert this instruction into machine code? Definitely will be asked. Yes, you need to translate it. Definitely will come in test 1 in finals also. So all these things are practically every single thing that we're doing chapter 1 will be asked. So we have a particular instruction just now. Actually here we have two instructions, right? Move LB1 and ADDWF hex 10 working register banked. But we will focus on ADDWF because we are looking at instruction format. Byte oriented instruction format. So we will do that. Move LB we will do when we come to literal oriented categories instructions. So how do we actually convert this instruction? First step, we actually write down the instruction that we want to convert, which is ADDWF hex 10, comma, W, comma, banked. And then on top of it we write the actual instruction with the fields, which means here you see the first one, ADDWF F, comma, D, comma, A. Write it on top of the instruction. Why? So that we can identify which is F, which one is D, and which one is A. Is following the sequence, right? F, comma, D, comma, A. So we write on top F, comma, D, comma, A. Is that okay? Okay. Then the third step, we write down the machine instruction from the PIC 18 instruction set. So this one is the ADDWF FDA. So what is the machine code? 001001DAFFFFFFFF. So write it down. 001001DAFFFFF. Now we need to substitute the value of D, A, and F. So I'm going to use a different color. 001001 is the same. D, what will be the value of D? Because we write capital W, right? What will be the value of D? 0. This is what I said you need to memorize. Capital W, D will be 0, F, D will be 1. The value of A is now you have written banked. So what will be the value of A? 1. So you write 1. So that also you have to memorize. I told you, right? If you have banked, the value of A is 1. If you write A, capital A, the value of A is 0. Now the remaining is the 8-bit file register address. Where can you find this 8-bit file register address? There, hex 10. How can you convert this? 1 is 0001, 0 is 0000. Did you all know how I got this? This is 10, hex 10, right? So you're done. But we always don't leave in binary format. We try to express the machine code in hex. So the final answer will be hex. So what is the first one? First digit? A, yeah. The first digit, this one. Oh, you can't see where I'm pointing. The first digit 0010 is what? 2. What is the second digit? 5. Of course, the last one again you get back the same thing, right? Hex 2510. So this is the machine code for ADDWF hex 10W bank. How many bit is this? The answer, hex 2510. How many bit is this? 16 bits. So this is the lower byte and this is the higher byte. Hex 10 will be stored in the lower address of program memory and hex 25 will be stored in the higher address of program memory. Is that okay? Next week onwards we will start using MPLAB. So we will use MPLAB again. We can see in much more visual format how these instructions are stored in program memory. I will send you the link for you to actually to learn how to use MPLAB. So this is the machine code. What happens if the D changes? If W is capital F, what will change? This will become 1, right? This will be 1. If this is F, this will become 1, and what will become this value? This will become 7. So the new is hex 2710. Same thing applies with bank also. If you write capital A, this becomes 0. So accordingly. So this is how you convert. So any question?